Friends, I am going to discuss one more lecture. Show that del of f of x equal to f dash r plus 2 by r into f dash r. This is also one of the important theorem in vector calculus. And we know that del of f of r means it's a gradient of f of r. Gradient means I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. In this scenario, I can write it down dou by dou x of f of r plus j into dou by dou y of f of r plus k into dou by dou z of f of r. So we can make it a differentiation with respect to x. Already you know that in earlier my videos, r is a function of f of x y z. So derivative of x means here f of r derivative is, already you know that here is f dash r, and r derivative is dou r by dou x. Similarly, we can do j into f dash r dou r by dou y, k into f of r and dou r by dou z. Already you know that here is dou r by dou x is, we can substitute x by r. Earlier videos you know that r is a positional vector, xi bar plus yj bar plus zk bar, and r square is nothing but x square plus y square plus z square. In that scenario, dou r by dou x is nothing but x by r. You can substitute dou r by dou x is nothing but x by r. Similarly, dou r by dou y is nothing but y by r, and dou r by dou z is nothing but z by r. So this is nothing but after substitution is made over, then we can again apply divergence of gradient of f of r. Divergence, first del is nothing but divergence, and the second one is nothing but a gradient f of r. So that divergence is nothing but here already you know that I into dou by dou x plus j into dou by dou y plus k into dou by dou z is multiplied by this equation. So equation 1, and then I dot I becomes 1, so that I can write it down dou by dou x of f dash r into x by r, dou by dou y into f dash r into y by r, and dou by dou z into f dash into z by r. So that you can make it a differentiation very carefully. Here only this one is product of two variables, so I can keep it suppose here I can keep it this one constant, and the differentiation of this one is nothing but f double dash r, and r differentiation is x by r. So this carefully we observe that this one is a constant, and the next one is, this one is keep it as constant, this one is keep it as constant. So f dash r is constant. Here you can apply quotient rule, u by v formula, v into u dash minus u into v dash by v square. So r is nothing, r is a constant here, and the derivative of x is 1, and x is a constant, and the derivative of r is nothing but dou r by dou x divided by v square is nothing but r square. Similarly, we can do this one and this one. After differentiation is over, then I can write it down here dou r by dou x is nothing but x by r. You can substitute, here is nothing but x by r. So here x into x is nothing but x square by r square. So in that scenario I can write it down this one. Here is r square is keep it outside of the bracket, so that I can write it down f dash r by r square into multiplied by here, and then this one is this. So, and similarly I can do the same procedure here also. After simplification is made over, here f dash r by r square is take it as a common. So same thing is there in second term and third term. I can take it common as x square plus y square plus z square. Here is f dash r by r in this term is there in respect of y and z term. So three terms are there. I can write it down 3 into f dash r by r, and here I can take it common, minus f dash by r square is common. Here is x square plus y square plus z square by r square. Already you know that this one is nothing but r square, so I can substitute here r square by r. So that here what we get, f dash r, here r square both were cut down. Here is 3 f dash r by r minus f dash r by r, so that 3 terms is subtracted from one term, so that we get this one. Hence theorem is proved. This is one of the very important theorem.